the ocean. Vast, mysterious, and holding secrets we've only just begun to uncover. Covering over 70% of our planet, its depths remain one of the last true frontiers. For centuries, we've gazed at its surface, wondering what lies beneath. And we're not just wondering, we're exploring, thanks to a new generation of pioneers. But these aren't human divers braving the crushing pressure. They're robots. Aquatic robots are mechanical emissaries to the deep. Today, we're diving deep, literally, into the incredible world of underwater robotics. We'll explore how these machines are built, what incredible tasks they perform, and what discoveries they're helping us make. From mapping unknown seabeds to finding strange new life forms. So, grab your virtual scuba gear, because we're about to journey to the bottom of the sea. First, let's talk about the challenges. The deep ocean is one of the most hostile environments imaginable. The pressure is immense, capable of crushing a submarine like a soda can. It's pitch black, colder than your freezer, and communication with the surface is incredibly difficult. Radio waves, which we rely on for everything from Wi-Fi to GPS, don't travel well through water. This means our deep-sea explorers have to be tough, smart, and, most importantly, autonomous. Enter the AUVs, or autonomous underwater vehicles. Think of these as the self-driving cars of the ocean. They are pre-programmed with a mission, released from a ship, and sent on their way to explore for hours, days, or even weeks at a time. They use sonar to map the seafloor in breathtaking detail, creating 3D charts of underwater mountains, canyons, and hydrothermal vents. They're equipped with sensors to measure water temperature, salinity, and chemical composition, giving scientists a vital snapshot of the ocean's health. One of the most famous AUVs is Bodie McBoatface. Yes, that's its real name. Despite the silly name, its work is serious. This long-range AUV has traveled under Antarctic ice shelves, collecting data from places no ship could ever reach, helping us understand how climate change is affecting our polar regions. These AUVs are our tireless surveyors, painting a picture of the ocean floor we've never seen before. But what if you need to do more than just look? What if you need to interact with the environment, collect a sample, or turn a valve on a deep-sea oil rig? For that, you need a different kind of robot. The ROV, or remotely operated vehicle. Unlike AUVs, ROVs are connected to a ship on the surface by a long cable or tether. This tether provides power and allows for real-time communication. Pilots sitting safely in a control room on the ship can see through the ROV's cameras and control its robotic arms with incredible precision. They are essentially the pilot's eyes, hands, and ears in the deep. You've probably seen footage from an ROV without even realizing it. Remember those stunning images of the Titanic wreck, resting silently on the seafloor? It was captured by an ROV? These machines are the workhorses of the deep sea. They are used for everything from scientific research and archaeological expeditions to commercial tasks, like inspecting underwater pipelines and cables. Some of the most advanced ROVs, like Hercules and Argus, work in tandem. Argus acts as a floodlight and a steady camera platform, while Hercules, the main vehicle, uses its powerful manipulators to carefully collect samples of delicate corals, strange deep-sea creatures, or volcanic rocks from hydrothermal vents. The dexterity of these arms is amazing. Pilots can use them to place a sensor, grab a rock, or even gently scoop up a fragile jellyfish. But the innovation doesn't stop there. Scientists are now looking to nature for inspiration, creating a new field called biomimicry. Why build a clunky, box-shaped robot when millions of years of evolution have already perfected underwater movement? Meet the bio-inspired robots. There are robots that mimic the graceful swimming of a manta ray, using flexible fins to glide efficiently through the water. Others look and move like fish, using a tail to propel themselves, making them quieter and less disruptive to marine life. There's even a robotic octopus with soft, flexible arms that can squeeze through tight spaces and grip objects of all shapes and sizes, just like the real thing. These soft robots are a game changer. Traditional robots are rigid and heavy. If they bump into a fragile coral reef, they could cause serious damage. But a soft robot made of flexible materials can gently interact with its environment. This is crucial for studying delicate ecosystems without harming them. Imagine a soft robotic jellyfish pulsing through the water, its sensors collecting data without disturbing the animals around it. This is the future of marine biology. So, what have these robots actually found? The discoveries are nothing short of spectacular, as they've discovered hundreds of new species, from bizarre-looking fish with translucent heads to ghostly white crabs that thrive near scorching hot hydrothermal vents. These vents, often called black smokers, are cracks in the seafloor spewing superheated, mineral-rich water. Scientists once thought life couldn't exist in such extreme conditions, but ROVs revealed entire ecosystems teeming with life that thrives not on sunlight, but on chemical energy, a process called chemosynthesis. This discovery completely changed our understanding of where and how life can exist, not just on Earth, but potentially on other planets or moons in our solar system. These robots have also become our underwater archaeologists. They've explored ancient shipwrecks, like the Antikythera wreck in Greece, recovering priceless artifacts that tell us stories about our past. They allow us to visit these submerged time capsules without disturbing them, preserving them for future generations. Furthermore, these aquatic robots are on the front lines of environmental monitoring. They track the spread of oil spills, measure ocean acidification, and monitor the health of coral reefs. They provide the critical data that policymakers and scientists need to protect our oceans. They are our eyes beneath the waves, our sentinels guarding the health of the blue heart of our planet. The future of ocean exploration is a collaborative one, where humans and robots work together. We're seeing the development of smart swarms of robots that can communicate with each other, dividing up a large area to map it more quickly. We're developing better power sources, so UVs can stay submerged for months or even years. And artificial intelligence is making these robots smarter, allowing them to make decisions on their own, identify objects of interest, and adapt to unexpected situations. Perhaps one day, we'll have a permanent robotic presence in the deep ocean, a network of sensors and mobile bots constantly sending back a live feed of the last unexplored frontier on Earth. From mapping the abyssal plains to searching for life in the darkest trenches, aquatic robots are extending our reach into a world that was once completely inaccessible. They are our proxies, our pioneers, our partners in discovery. The deep sea is no longer a place of pure mystery. It's a place of science, of discovery, and of wonder, all thanks to these incredible machines. They remind us that there is still so much left to explore and understand about our own planet. Thank you so much for joining me on this deep dive into the world of aquatic robots. If you found this journey as fascinating as I did, make sure to hit that like button and subscribe for more adventures into science and technology. Let me know in the comments what you think is the coolest thing about these underwater explorers. Until next time, keep exploring.